Hello friends, welcome to lecture number 4 of Frobenius method, and here we're going to solve this equation. Okay, and this is case 4 where you see roots of the initial equation are distinct and they differ by an integer. Okay, and one more situation you may face here. One or more coefficients are indeterminate, but it is not necessary that you're going to face this situation in all the problems of this case. Okay, so now let us solve this problem, this equation. So you may follow on Insta. You can follow me on Insta. This is my Insta ID, Lakhyajit 123. So okay, the given equation is this. This is the equation, right? So we are going to solve this equation. So in order to solve this equation, we have to consider the solution. So y is equal to summation from r is equal to 0 to infinity ar x to the power m plus r, right? So if you differentiate it with respect to x, so let's find y dash. Y dash means derivative of y with respect to x. So from r is equal to infinity, and if you differentiate, you're gonna have ar m plus r into x to the power m plus r minus 1, and if you differentiate it again, you're gonna get this y double dash. That means second order derivative of y with respect to x, summation r is equal to 0 to infinity ar m plus r x to the power m plus r minus 1 into x to the power m plus r minus 2. That's what you're going to have, and let us consider this given equation as equation number 1. Okay, so here you see, if we put those expressions of y dash y double dash in equation number 1, substituting the expressions of y double dash in equation number 1 in the given equation, we're going to have this equation, right? Let me write this one first. Okay, so this is the equation you're gonna have. So here what we have done, we have put this 3 here. So y double dash is replaced by this result, y dash is replaced by this result, and y is replaced by this result, and that is what we have done here. So hope you have understood this now. And here what we can do, just multiply this one with this, then this minus 2 and this plus 2 will be cancelled, right? Similarly, if you multiply this one with this terms and this one with this terms, then what you're gonna have, so we're gonna have this situation. You see, we're gonna have this equation. Now you see, I have multiplied x square with this, then we have got m plus r minus 2 plus 2, so that's why x to the power m plus r, right? Similarly, let's multiply x first with this term, then we're going to multiply x square with this term. And first multiplying x with this, then what we have got, if you multiply x here, if you multiply x, then you're going to get m plus r minus 1 plus 1, then it's going to be again m plus r, right? So here you see, that's what we're gonna have, right? Then here we have multiplied this one x with this, right? Now what we're gonna do, we're gonna multiply x square with this. So in that case, what we will get, we're gonna have this, right? M plus r minus 1, and as there is x square, so it's gonna be plus 2, which gives m plus r plus 1, right? So we're gonna have this result, right? And similarly, if we multiply x with this, then you're gonna have m plus r plus 1. Okay, right? Then minus 9 is multiplied, with this, so we get this result, right? So hope you have understood now. Now let me go to new slide. Here is the last result we have got. This is the last result we have got. Okay, let me write here. Okay, Now we're going to simplify this. So what we're going to do here, you can see we can take what are terms we can take common. Here x to the power m plus r, and here also x to the power m plus r, and here also x to the power m plus r. So we're going to take ar and x to the power m plus r, ar x to the power m plus r, ar x to the power m plus r. We're going to take this common, okay, from these three terms. So then what we're going to have, so this is the result we can have here. And one more thing, I forgot to write this one, x to the power m plus r is taken common, okay. Then similarly what we can do, we can take this common, that x to the power m plus r plus 1 ar, and this one, okay. So if we take this common, then what we're going to have, then our result should be something like this. So this is what we're going to have, right, equal to 0. Now you see, equating the coefficient, the smallest possible coefficient, that is x to the power m. How to obtain this? Putting r is equal to 0, right? So putting r equal to 0, or yes, so putting r is equal to 0, here you see coefficient of x to the power m is equating the coefficients of x to the power m to 0. How to do that? Putting r is equal to 0 in the first summation, right? And here you see, here we have put 0, right? And one more thing, in order to make it x to the power m, so here we had x to the power m plus r plus 1. So in order to make it m, we must put here r is equal to minus 1, but it cannot be put, r cannot be minus 1, r starts from 0, right? So that's why we're going to ignore this part, okay. So as r is equal to 0, from r starts from 0 to infinity, right? This is positive integer, so we cannot put r is equal to a negative number. That's why we're going to take the coefficient only in this term, right? So hope you have understood this. And doing so, what we're going to have, we're going to have this result. This implies this, right? So equal to 0. So just multiply these two, and here you see minus m plus m gone. Then you're going to have this result, right? And here remember one more thing, this a naught cannot be equal to 0. That's why m square minus 9 must be 0. So m square minus 9 is equal to 0, since a naught cannot be 0. And this is solution of this equation will give you m square is equal to 9, m will be plus minus 3. On taking square root, we're going to get m is equal to plus minus 3. So we have got the two roots, which are m1 is equal to minus 3. So let me take m1 as plus 3, then m2 as minus 3, right? M2 as minus 3. This is minus 3, okay. So here you can see m1 is not equal to m2, and their difference is distinct. The difference belongs to z, okay. If you find a difference here, plus 3 minus minus 3, they're different by an integer, that's 6, belongs to z, right? So hope you have understood this. So now here you see, let me go to a new slide, okay. So let me write this. Let me write this equation again. So here you see, okay. So I have written this equation again. I have written this equation again because so that I don't need to go back to the previous slide again and again. So now equating the coefficient of x to the power m plus 1 to 0 and putting so let me equate the coefficient of x to the power m plus r. Okay, then putting r is equal to r minus 1 in the first summation, and in the second summation, as you can see, this is already x to the power m plus r, so that's why I need to put only r is equal to r minus 1 here only. If you put r is equal to r minus 1, then m plus r minus 1 plus 1, that's gonna give you m plus r, right? X to the power m plus r. So that's what we have done. So instead of using this symbol, write in the second summation in the word, okay, in words. Okay, now let's proceed. Okay, so that's what we have got, right? So this is the coefficient of this part that we have got from this part, coefficient of x to the power m plus r, and from this what we're gonna have, we're gonna have this, right? So here we have put r is equal to r minus 1, right? R minus 1, here also put r minus 1, and here also put r minus 1. That's what we have done, right? And doing so, what we have got, we have got this. Okay, now if you simplify this, what you're gonna have, right? So just what we have done here, we have taken this common, then within bracket we have got this. So here minus 1 plus 1 again, right? Minus 1 plus 1 cancel, so this is transferred to other side, and then it implies this, right? Here you see, if you multiply this one with m plus r and m plus r, then you're gonna have m plus r whole square and minus 9, so 9 can be written as 3 square. So now apply a plus b into a minus b formula, then you're gonna get this result, right? Now from here we can find a1. This is a1, right? So putting r is equal to 1, if you put r is equal to 1 here, and here also r is equal to 1, then it becomes a naught, this term becomes a naught, and this becomes a1, right? So hope you have understood this. Similarly, you can find r2 as well. If you a2 as well, so putting r is equal to 2, so we're gonna get this, right? So put r is equal to 2 here as well. Now replace this a1 by this value of a1 that we have already got. Now put this one here, then what you will get, so then you're gonna have this result, right? And similarly you can find a3, a4, a5, so on, right? You're gonna have a3, putting r is equal to 3, you're gonna have this, and now put the value of a2 here. This is the value of a2, now put here, then you're gonna have this, right? Similarly you can find a4 as well, and so on, right? So now let's go to the next slide. So here ym is equal to, let me write ym first, this one, this is the result we're gonna have. Ym is equal to, from where I have got this, I'm gonna show you now just what wait. So here you see, as we have already considered the solution, y is equal to summation r is equal to 0 to infinity ar x to the power m plus r. Now if you expand this, if you expand it, then you can write this one in terms of series like this. So we can express this way, right? Now here you see, putting the coefficients that we have obtained in the previous slide, putting the expressions of the coefficients a1, a2, and a3 dot 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 so on, right? We're gonna have this result, this one. So here I am writing m means here we have got m's here, right? So this is the solution for m is equal to m, you can say. So then we're gonna obtain the solution for m is equal to m1. That means we're gonna put 3, then we're gonna get the solution of, that means value of y for m is equal to m2, that means 4 minus 3 as well. So we're gonna obtain those as well, right? So hope you have understood this. Now for m is equal to m1, we have taken plus 3 as m1. So ym is equal to ym is equal to this. Let me write ym is equal to this first. So I'm going to show you how to obtain the ym is equal to 3. So this is the series we have got, right? This is the result we have got. So what we can do here, so here you see, just for m is equal to 3, you have to replace this m by 3, this m by 3, this m by 3, replace all the m by 3. Then what you gonna have? So from this, you see, if you replace, just wait, let me show you. From this term, what you will get? 1. From 1 we're going to get 1 only. So here from the second term, what we're going to have, if you put m, so 3 plus, the m is equal to 3, then 3 plus 1 by 3 plus 4 into 3 minus 2, that's what we're going to have, which becomes 4 by 7 into 2, that's what we're going to have. And from this term, what we're going to have, 3 plus 1, so m plus 1 means 3 plus 1, that's going to be 4, and m plus 2, that's going to be 3 plus 2, that's going to be 5, divided by 3 minus 1, that's going to be 2, and 3 minus 2, that's going to be 1, right? And 3 minus 4, that's going to be 7, and 3 minus 5, that's going to be 8, right? That's what we're going to have. And similarly, from this term, what we will get, m plus 1, that means 3 plus 1, that's going to be 4, then 4 plus 2, 3 plus 2, that's going to be 5, 4, 5, then we're going to have 6, right? You see the pattern. First we have got 4, then 4 into 5, now we are getting 4 into 5 into 6, then here we will get 2 into 1 into, then m, that's going to be 3, then 7 into 8 into, then we're going to have 9. Okay, if you put 3 here, okay, that's what we're going to have. So you can write this denominator in this pattern as well, in, you know, increasing order as well, 1 into 2 into 3 into 7 into 8 into 9, that's how you can write. Okay, so hope you have understood this. So that's why what we have got, put m is equal to 3, okay, in its and every term. Okay, so you don't have to mention this line here, because in order to explain, I have written all these things. You can write directly the result, what will be the result, you're gonna obtain, putting m is equal to 3. You can write directly here. Once you have written for m is equal to 3, just you can write the result directly, what you gonna have, putting those values m is equal to 3 here, okay, instead of writing this expression. So now let me go to the next slide. Here you see ym is equal to, what we have obtained after putting m is equal to 3, we have obtained this result, right? And dot dot dot, so on. Now for m is equal to m, for m is equal to m, we have this option, we had this expressions, we had this results. Let me write that result again. Okay, you don't have to repeat this one, just in order to explain, I have repeated this. Just I have written the expression for y is equal to m, not y is equal to m, y for m is equal to m. That means I have written the result of y in terms of m only. Now put this m is equal to, putting m is equal to minus 3. Okay, m in its and every term. Okay, m2 is equal to minus 3. Now if you put m is equal to minus 3, then what you will get? Okay, so if you put -3, then you're gonna get this result. Okay, so I'm not gonna explain this. You hope you can do this because you are a student of B.Sc. So just simply put the value of m is equal to -3, then you're gonna have this answer. Okay, very simple thing. That's it. So this is the solution you're gonna have, right? So now here you see, just let me go to the previous slide again. So here we have got y for m is equal to m2, that is -3, and we have got the value of y for this for m is equal to +3 as well. So this is m is equal to +3, value of y is m is equal to +3, and value of y for m is equal to -3. Then this should be the form of the solution. Now let us replace these two by their respective values, and doing so in the next slide we're going to get this solution. This is our solution. This is the solution.